Hey everyone, welcome to the next Kubernetes Happy Hour. Today we'll be going over a topic that is near and dear to me, the etcd manager. So the etcd manager is obviously what its name implies. It manages etcd for you inside your Kubernetes clusters. Today, I think, is our 40th episode of the Kubernetes Happy Hour. So I've been doing these every other week recently. Just been very, very busy. So I try to peel off an hour of time and talk to you guys about what I've been doing recently. So what I've been doing recently is working with etcd Manager, and I was um, moving from one subnet in Amazon to another subnet, and I needed to know the nitty gritty details of what was going on with etcd Manager in order to facilitate migrating my cluster, abandoning one subnet. So etcd, as everyone knows, is the brains behind Kubernetes. It handles events from Kubernetes and it handles the state for Kubernetes. So traditionally, you out of the box set up a cluster of size 3. So it's a distributed key store, meaning that with 3 involved, it's got a quorum protocol. So you can withstand one going down with a cluster size of 3. But if you have a cluster size of 5, you can withstand 2 going down because you still have 3 that make up a majority. So utilizing those two key thoughts, how do you go from one subnet to a new subnet inside Kubernetes? So you can't just go into a cluster member and switch the subnet through configuration. It doesn't work that way. So what you have to do is if you start with a cluster of 3, you have to grow your cluster to 5. And when you grow your cluster to 5, you end up putting the 2 new members in the new subnet. And then when you have 5 and that's all healthy, what you want to do is you want to shrink back down to 3. But when you shrink back down to 3, you want to abandon the old subnet. And that's how you achieve migrating away from a subnet inside Amazon or inside GCE. It's the same concept. So, and the reason why you want to move away from a subnet inside Amazon could be many reasons. My reason in my case was the instance types that I needed to run inside my cluster were not supported in one of the subnets that I was using, one of the availability zones within the region. So it's a dirty little secret, or maybe it's not such a dirty little secret, in that all of the availability zones that make up a region inside Amazon usually don't offer the same products. So there's not parity from one availability zone to another. So you'll find that with instance types, and you'll find that with other things too, and that things aren't ubiquitously available across the board within a region. And so in some cases, it's because some of those data centers are old and Amazon has decided not to invest in those data centers, or maybe they can't invest in those data centers and bring the new instance types up for whatever reason. So they never introduced new instance types into some regions, and so, or some availability zones rather, within the region. So sometimes that's just an example of one case where you need to migrate away from one availability zone within the region to a new one. And to do that, I had to understand what etcd Manager was doing to grow the cluster to size 5 and to shrink it back down to 3. Yeah, so that's why I wanted to talk to you guys about that today, is because I've had my sleeves rolled up in understanding what was going on and how that was working. I use Kops obviously to manage our clusters. So today I've spun up a cluster on my own personal account that's going to start with 3. I'm going to walk you through what etcd Manager is, what it does, what its purpose for is for me, what its purpose is. And then what I'm going to do at the end of this, I'm going to spin up 2 new members of my etcd cluster, and you guys can see the actions that take place when that happens. So without further ado, I'll show you my cluster. So let's go to the console here and make sure it's big enough for you guys so you guys can see it. So you can see here, I'm actually inside the source code of etcd Manager here. I did a fork of it, and I'm doing some changes to it to play with stuff. But I don't necessarily need the source code to go over what I'm going to talk to you guys about today. So let's look at my cluster. This is my cluster inside my personal Amazon account. So we got 3 workers and 3 masters. I made this a couple hours ago. I'm on version 112.8 of Kubernetes. The latest 112 version is 112.9. This is 112.8. Um, I don't run. I don't think I need anything in 112.9. So out of the box, Kops will set 112.8 for your Kubernetes version in Kops version 112.1. So that's the version of Kops that I'm running right now. So you go back here. So let's look at Kops. Let's look at my cluster. So this is my cluster here. You can see that that's the name of my cluster. It's an AWS, and these are the zones or the availability zones that I'm using. I'm using US East 1C, US East 1D, US East 1E. Okay, so let's look at my cluster a little bit more. Let's look at the cluster config. So here are my subnets. I think that what I want to concentrate on today is this section in here inside your cluster config, which is your main and your events etcd members. So out of the box, etcd Manager will create a etcd version 3.2.24 with TLS enabled. So TLS enabled means that when a cluster gets created, all the services that are offered by the cluster peers are going to be TLS enabled. And that's mutual TLS, so there'll be a client cert and a server cert on both sides. And that's to make sure that only the peers that you want to participate in the cluster are actually participating in the cluster. So you can't have any rogue members spinning up and talking to your cluster. And they would only be able to do that is if they had the proper cert issued by the proper CA. Right, and they trusted on their side who the server CA was. So in order to facilitate that, etcd Manager steps in. One of the functions of etcd Manager is to distribute the certs in such a way that when the master nodes come up, they have the proper certs. Another thing, so let's talk about at really high level what etcd Manager brings to the table. So what etcd Manager brings to the table is first and foremost backups. So backups meaning, I think out of the box every 15 minutes it's going to take a backup of your etcd cluster. So there's two clusters. There's etcd main and there's etcd events. That's why there was two sections inside my my cluster config, one for the events and one for main. Every 15 minutes it gets backed up. So where does it get backed up to? Well, Kops operates under the premise that there's an S3 bucket somewhere that you define beforehand, and you set your environment variable called Kops state bucket or something. Let's see what that is. So let's get out of here. Let's look at my environment. Let's look for Kops. So it's called the state store. So this is the S3 bucket where Kops is going to keep your state for your cluster, and inside that bucket is where all the backups go. So I'll show you what that looks like right now. So there's three main things that that etcd Manager does for you. The first thing it does is backups. The second thing it does is it manages the DNS resolution for etcd hosts. So it would go in and on the node itself actually update the DNS for the what members make up the cluster. So it's keeping track of that locally. So in essence, what it's really doing is keeping track of state. It's keeping track of what members make up your cluster and where they are, and it does that through the etc host file. So the node knows how to get to the other members of the cluster. And then the next thing, the third final thing it does from a major theme point is it handles upgrades and downgrades for you with the etcd version. So etcd Manager ships out of the box with etcd built into it, and then the pre-built versions are in there. You pick which version you want. The default one is 3.2.24. So if you don't pick it, it's going to pick 3.2.24, which for Kubernetes 1.12, 3.2.24 is fine. Kubernetes 1.14, I think the recommended version is 3.3. And when I get into this, I'll show you where these versions are. So the first thing I want to do is I want to show you guys what things look like inside the S3 bucket when there's backups taken. So this is my bucket right here. You can see this is on S3. This is my personal Amazon account. So go here. I spun this up a couple hours ago. So within this bucket here, there's some Kops specific stuff, right? Which is cluster spec and config. I'm not going to go into that today. We're going to go into the etcd Manager stuff. So etcd Manager will go here, and it'll create this backups directory here. And you can see here's etcd for the backups. There's main events. Let's look at main. And then you'll see here, these are all the backups that have been taken. Let's refresh and make sure. Oh, the one was actually just taken like maybe 10 minutes ago. So this is the most recent backup right here. It's taken every 15 minutes. You go in here, and you can see there's a gzip file, which is the backup. So this is going to be a binary thing. It's not going to be something you can manipulate. It's going to be the etcd backup. And this is going to be the metadata, which probably has a timestamp and some other stuff. Let's take a look at what's in here. Let's look at the etcd meta. Okay, I downloaded that. Let's switch up my terminal so you guys can see what I'm looking at here. Okay, let's see what's in that meta file. I think it's underscore etcd backup in etcd backup.meta. I think there was the one. So what it does is it tells you basically the timestamp it took, the etcd version, and at the time it took it, what was the etcd version, and the number of members of the cluster. So I have 3. So there's 3 members of the cluster, right? And that matches up with what we see using version 3.2.24. Okay, so there's that. So let me show you some more detail. So there's that's more like a metadata about the backup file itself, what it represents. But there's some control structures here that are very important. Let me go show you what those control structures are there. Inside, so there's the backups themselves, which are the gzip file and the meta file. It gets put up there by etcd manager. And there's also state that's up here too. That's very important to know that there's state up here. So let me show you the state that's up here. Okay, bear with me as I switch. So let's go here, let's go main. There's a control folder. Aside from all of the backups you have, there's a control folder here. And we're going to look at this one. There's a created, so this one is a timestamp and there's a spec. So let's download that spec file. So this is going to be, and now let's take a look at it. This is going to be the cluster state, or what the controller within etcd manager thought the state of the cluster was. So let's take a look at that. Okay. That goes into my downloads, and then to what we got here, cluster spec. And here you see the member count is 3, and etcd version of 3.2.24. So that's used, that has nothing to do with backups. What that is etcd manager is keeping a state of how many members make up the cluster and the version. So that's important to know that that state is being stored up there. So when you change to 5 or go back from 5 to 3, this gets updated, right? Or if you change the version, the current version of the cluster gets updated. So there's this state, which is up in S3, and there's also state that's stored on the persistent volume on disk. So one of the jobs of etcd manager to do is it wraps obviously etcd. So what it does is it starts up etcd only when the volume that etcd requires to run is mounted to the host. And then it starts up etcd. And within that mount, you'll see some state as well. So let's take a look at that. While we're talking about state, let's take some look at that. So let's go to the terminal again here. Okay, so let's look at the nodes. Let's find the pods. So these are our pods. Let's pick one. It doesn't have to be the master. So obviously in etcd you have a master and you have 2 slaves. If you have 3, let's go into this because I don't have SSH access into it because it's a local subnet, and I don't have a Bastion host, so that's not going to work. So I'm going to SSH into this. Or I'm going to shell into this rather. I should tell it. I need to tell it the namespace. Okay, great. So this is etcd manager itself. So let's look. Let's see what's going on. So etcd manager is a privileged container. So it's actually able to view things that are on the host itself. So I'm on the host. So when I do a PSEF, I'm actually seeing everything that's running on the host. So what I wanted to do was show you where etcd is. And so this is etcd manager, the container itself, and it ships with all these different etcd versions. You got 2.2.1, 3.1.12, 3.2.18, 3.2.24, which is what we're running, and 3.3.10. 3.3.10 is a version that's over Kubernetes 1.14. So it recommends to run with 3.3.10. So I imagine that when we go from Kubernetes 1.13 to 1.14, part of the recommended upgrade path is to switch to use this new version of etcd, which is 3.3.10. Okay, so back here. So you can see that it actually ships with all these versions, and we're using etcd 3.2.24. So let me show you 3.2.24 what's in there. So you'll see etcd-ctl in there, and you'll see etcd itself. There's etcd-ctl and etcd itself. So those are all the different versions, and that's how this thing is able to manage upgrading between versions. Now, note to the viewers here. You can't go between, you can't jump two major versions. You can only jump one major version at a time. And between minor versions, you can only jump one minor version as well. So you can't go from etcd 3.0 to etcd 3.2. You can go from 3.1 to 3.2, but you can't go from 3.0 to 3.2. And moreover, you can't go from, say, etcd 2.2.1 to directly to etcd 3.2.24. You have to go to the first version of etcd 3. When you do the etcd 2 to etcd 3 upgrade. So that's just a side note on the side. There's a function inside etcd manager that enforces that. So if you try to jump a version that's not allowed, it'll tell you you're not allowed to do that. But you are allowed to go from between minor versions of the same version. So you can go from the two versions of 3.2 there, or you can go from 3.2 to 3.3. So etcd manager will support that. And so note to everybody out there watching too, is that etcd manager itself will probably be replaced in the future by etcd ADM, which is the next generation of this product. So I think everything started with etcd operator. And then the next generation was etcd manager, and then obviously the next generation after that is going to be etcd ADM inspired by kubeadm. So they're taking a kubeadm kind of model and they're going to apply it to etcd. So etcd manager in the long term would be superseded by etcd ADM. So that may be in the future for any kind of open source projects out there. But currently today we're going to talk about etcd manager, so we're not going to worry about that. But just know that etcd ADM is out there, and the open source community is going towards that as a true north, like a target of what they're going for. Okay, so let's go back here. So I showed you guys how etcd manager has bundled up everything inside here. And what I wanted to do was show you guys where the state is. So the state is actually, the mounts are here. So you can see that I got two mounts here. I got one for etcd events and one for etcd main, because there's two clusters going here. So let's pick one. Master, I don't know which one this is. We'll see which one it is in a second. So you got state file here. You see that state files? Let's see that. So the state file keeps track of what the peer that I'm currently on thinks the state of the cluster is. So you see all this gobbledygook. Know that this state file, you can't edit that state file. Don't try to edit that state file. You know why? Because it's a protocol buffers file. You can't edit it. It's not a text file. I just catted it to show you guys what's in there because some of the text shows up, and you can see that there's a little bit of state being kept in that file. Obviously called a state file, so there's state being kept in there. But it's binary file, it's protocol buffers file, so if you want to change it, don't use an editor to change it because it's a binary file. Okay, but just know that the local etcd controller, etcd manager controller, is keeping state itself locally inside this state file. So it uses the state file itself when it restarts. It looks for the state file and it discovers from the state file who the peers are in the cluster, the cluster size, the cluster version, and what the token is for the cluster. So it can enforce who's trying to be a member of the cluster, if it becomes the leader of the cluster, or if it doesn't. This is actually a good segue to start talking about etcd manager itself. is that etcd manager runs on all three of the nodes that are inside your cluster, but only takes action on one of them. So it's in a loop on all three of them, but it tries to become the leader. And when the one becomes the leader, that's the only one that actually does anything. All the other ones, when they discover that they are not the leader, they go back to sleep and then they wake up, whatever that interval is. I think it's 10 seconds. And only the leader is the one that's going to actually do stuff. So what are some of the stuff that the leader does? So the leader, what it does, the first thing it does is it looks at its state and it sees, okay, these are the members that I think make up the cluster, right? And what it does is it iterates through them, and it calls a service called getInfo on the peer, and then the peer responds back with information about itself, right? What it thinks the current state is, and some metadata about itself. And the master controller will keep that information, and then it will go back to the peer and say, okay, give me the members of the etcd cluster, and those members come back, and those are actually the members that end up in the host file of the actual host. So there's some logic that happens after that where it takes those members that come back, and those members come back with an IP address, and come back with a name, and it comes back with some URL, how the peers can connect to it. And that stuff actually ends up in the host file. So let me show you the host file on this server here. Okay. So we're still connected here. So if I cat etc hosts, you can see that this is being managed by etcd manager. So you can see like you got three new entries here for that's events, and this one is for main. So there's a template function that's inside etcd manager that's updating locally the members of the cluster and how to get to them, and the DNS name for them. So the important thing is that these DNS names are important because this is the TLS cert that's hosted on this guy. Is expecting clients to come in with this name, and this is the IP address of that member of the host, that member of the cluster rather. So okay, so we've done that. So we see that backups are stored in S3. State is managed by the etcd manager, the leader. All three of them are running, but only the master is really doing anything. And that state is managed by that guy. So whenever there's a change in state, obviously, how does that leader publish out that change to all the other members so they also update their etcd host? Well, there's a gRPC layer that's built in for etcd manager, that whenever one controller needs to talk to another controller within the cluster, at that layer that sits above etcd itself, the etcd manager layer, there's a gRPC service, they call it peer service in here, that is able to, so whereby the controller manager, who's the leader, the etcd manager, the controller loop, who's the leader, is able to call through the service to the other guys because it has the peer info. So it understands where it is from an IP perspective. So it establishes a gRPC connection to those peers, and it calls a special service on that guy. And that special service will manipulate the etcd host file on the remote peer. So they're all in sync, rather. So that's a good thing, right? So everything's in sync. Sometimes things get out of sync, and I have some bug reports about that stuff. But for the most part, it works pretty nicely. So hats off to whoever designed that. It's pretty neat stuff to work on and to open up the hood on and look at. It's pretty code. So okay, so let's go back here. And maybe I can show you guys where is listening at. Let's see. I don't know if NetStat's installed on this. Nope. So let's get out of here. Okay, so the next thing I want to show you guys is what happens when I grow my cluster from 3 to 5. How do I do that? So you're gonna have to bear with me here. So what we have is we have 3 instance groups, right? One for, I think I'm in A, C, and D or whatever. It doesn't make a difference. It's arbitrary. So I have 3 master instance groups, right? What I'm going to do is I'm going to go into the cluster config, and I'm going to edit it to add 2 new members to my etcd clusters for main and for events. I'm going to reuse some of the instance groups types to do that. But for me to do that, out of the box, the master groups come with autoscaling groups that say max size of 1. So if I decided to spin up 3 new servers, it's going to not allow that because the autoscaling group is not going to allow that. So what I'm going to do is, first thing I'm going to do is go into the master instance group, and I'm going to spin that up to allow for 3. Because one of them is going to host 2 new ones. So I got to pick one that's going to have the 2 new ones. And then I'll go into the cluster config, and I'll tie together the new STD members to that new, the newly enhanced instance group. And then what I'll do is I'll apply it, and we'll sit back and watch, and then we'll eat the popcorn, and we'll wait for it to come up. And then when it comes up, I'll show you the changes that were made to the state. I'll show you the changes that were made to the etc host file. And I think that would be super interesting to see how this stuff kind of just coalesces. It comes together nicely when it comes to cluster expansion. The cluster going the other way is a little. I think that's not such a common use case, but I think the 99% use case is people want to expand their cluster. Usually shrinking your cluster is kind of an edge use case. But so we're not going to do that today. We're going to expand the cluster. I think that'll take us through up to the time that I've allocated for this talk. I know somebody asked me on the side for diagrams about etcd Manager and what it controls. I don't know. I think you could go to etcd Manager's README file on, because this is not something that I made. So I'll show you guys etcd Manager site that you can go to here. I think it's here. Could be here. It's right here. So this is the etcd Manager site. It's github.com/copio/etcd-manager. So this is the etcd Manager that's used by cops. So there's some information about here, about what it does. There's a talk. I think there's a documentation he's got here about backups and the architecture for backups. Yeah, backup structure. So this is like the backup structure of what's in that S3 bucket and what it looks like. You can see here's the meta file and what everything means in that meta file. So that's that. But if you want, this is the site. You can look at the code itself if you're interested. I don't know if you guys were seeing that. Were you seeing that? Oh, I'm sorry. Here's the site. So here's the site. You can see github.com/copio/etcd Manager. And there's a README file here you can start with to see if that kind of explains at a high level what you're looking for. And there's also here, there's a docs that explains the backup structure. What I was showing you guys before in the S3 bucket, the backups that happen every 15 minutes. It tells you about the spec file, and it tells you about the naming of the file. So yeah, and this is obviously where the source code is. So if you want to dig into the source code, you can definitely do that. Yeah. So let's get this show started. So let's do something fun. Let's expand our cluster. So this is my cluster. I'm not doing this on any kind of live cluster production or whatever. One thing is you always want to have backups. So the nice thing about etcd Manager is taking backups for you every 15 minutes. So you always want to have backups of your stuff before you do anything crazy like I'm about to do, like go from cluster size 3 to cluster size 5. You want to make sure you have a backup beforehand so you can always recover in case something goes horribly wrong, because this stuff is very high tech, I guess, cutting edge. And sometimes if you do something incorrectly, or if you don't understand what you're doing and you make a mistake, things can go horribly wrong, and you'll need to restore your stuff from a backup. So yeah, so let's do this. Okay, so let's do cops get instance groups. These are my instance groups, right? I'm gonna pick one for the master. I'm gonna pick the 1C. That sounds good. So let's edit this guy. So you do cops edit instance group. This guy. What we're gonna do is we got max size, min size. We're gonna say max size is 3, min size is 3. So this is gonna be the group that we're gonna pick. We're gonna pick 1C, okay? And then we're gonna edit our cluster now to use that. I think 1C, right? Yeah, 1C. Okay, so we're going to pick two new members of, this one is the main, so let's copy and paste this twice. And we're going to make this guy in C. And we're going to call this guy CA and CB. How's that? Okay, go down here and we'll do the same thing for the other etcd cluster. So you can see how etcd manager manages both of these etcd clusters. Okay. So it gives you a warning, and this is actually very helpful, is that it's warning me that they're in the same instance group. And why that's important is because if I go to 5, right, then I'll have 3 members inside the same availability zone. So if I lose that availability zone, I'll lose quorum because I'll have 3 in the same availability zone, which is okay because this is just a demo, but normally you wouldn't do what I just did. You would normally like kind of spread it out. But today we're going to have 3 inside the same availability zone, which is not recommended. I wouldn't do this in production. I wouldn't do this in QA. I wouldn't do this in dev. You'd want to split this out. So if you want the ability to lose an availability zone, it's the whole purpose of doing it. So, all right. So let's go back. But this is for a demo only. Okay. So let's do it. Let's run it. Update cluster. Update cluster. I think I have to give the cluster name. I don't think I can just do this. I think it's going to say, give me like, oh, there it goes. Okay, so there we are. Cluster changes has been applied to the crowd. So obviously I changed the instance group definition for 1C to have 3 members. So it's spinning up 2 new ones right now. And when those new ones spin up, they're going to be running etcd. And then hopefully they don't get confused because they're still running in the same subnet, but we'll see. Because sometimes there's an issue with mounting volumes if you're in the same subnet, but I guess we'll find out, and then we'll go from there. But whatever, live demo, we'll see what happens. I think it'll work though. So, all right, so let's do kubectl. Obviously, these nodes take a couple minutes to come online. So not there yet. So let me show you let me go to the console and we can watch them come up on in the Amazon console. So let's go here. Okay. So let's go to my EC2 dashboard and you'll be able to see them come up. Okay, spin, 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 and some have already come up because it says 8. I had 6 before, now I have 8. So those are the 2 new ones that have come up. You can see they're initializing here. They're not ready yet. So this is going to be master 1C, master 1C. These are the IP addresses there. M3 medium. They're in US 1C. Let's look at the tags. Tags, and you can see so we just have to wait for these guys to come up. So what's going to happen when these guys come up is the etcd controller, who is the master, is going to discover these 3, or the 2 rather, new ones, and etc host is going to be updated on the server where the master is running, and then it's going to spread it out, that information, to the other guys, the other existing members of the cluster, and then they're going to know about it. And then once they know about it, then they're all going to be allowed to talk to each other through peers because they'll be able to resolve each other's names. So let's look at the log files of etcd manager. One of the hosts that was there already, and it should probably start complaining soon because there's a convergence period of when it's being told about from a metadata from that S3 state of how many members make up the cluster. And when it sees that the two new members come on, they're not available yet until obviously the hosts come up and they're reachable. So there's a period where convergence happens. And then it goes from 3 to 5. And so let's take a look at those logs and see what's going on here. Okay, let's go over here. Let's get the pods again. And let's look at logs-f. Let's take the first one here. That's in the kube system. So you can see I guess this guy is actually starting to converge itself because it started streaming with the new guy. So you can see CA here. So this is the important thing here. Updating hosts here. So it's got E, it's got etcd C, it's got CA, it's got D, and so CB has yet to come online. So let's do this while we're waiting. Let's look at the state that's in the S3 bucket. I can show you the new state file because that new state file is going to have some interesting things in it. I just want to get rid of the old state file so I don't overwrite it. Let's see the cluster spec. Okay, so let's bring you guys over to the terminal over here. You can watch as I go, and I go get that S3 bucket stuff again. And let's look at the state of how the etcd controller updates the state inside the S3 bucket. Now, when I download this, it should say 5. It should say the version is 3.2.24. Okay. There's my bucket. And not cluster spec. I want to go into backups. Now we go to etcd. We go to main. There's a control. Go in there. And let me get the spec. Let me download that again. Okay, download that. I remember the old one. So when I cat out the etcd cluster spec, you're going to see the new one. So, okay, you can see that I remember the old one. So let's look at downloads. Etcd cluster spec. So you see there's 5. So now we got 5, right? Woohoo! So we did the cluster expansion just like that. So now we got 5. Awesome. So well, let's go and see the output of that log file now. Actually, it's going to say the CB is probably up on now. So CA is up. CB is probably up. Let's see. Let's check it. Look. Nope, it's not up yet. We got 4 guys here, so it's not up yet. So let's see. Let's do this. What I want to do is exec into that pod that I was doing before. Here he is. And okay, so you can see CA and CB are actually there inside, but the master hasn't come up yet. So you got CB and CA. You can see that it's got the IP addresses are different, so that's actually good. So yeah, it means that they're all running on individual servers. So I was nervous about seeing the same IP address, like one of the nodes running more than one, but it's not. So that's good. So they all have distinct IP addresses, which means that they're all running on those. So these guys are assigned. You can see that now I have a cluster of size 5 for etcd main and etcd events. You can see that the etcd host file is updated. And honestly, to tell you the truth, that's what I look at. When you see the etcd host file updated, that's when you know that you've successfully expanded your cluster. When that state gets into the etcd host file, then you pretty much an indicator that you're good. You're good to go. Everything beyond that is going to be local to the local etcd cluster. If you don't have the member join yet, there's probably something locally going on. But etcd itself, the cluster itself, thinks that there's 5, so that's good. So, and that reflects itself inside the etc host file. Okay, so let's get off of this. Let's see if our node came up yet. Yep, it came up. So 88 seconds ago, so we're good. 4223, that's that one, 4223. And this one is 6361, which is this one right here. So let's look at the log file now on this guy. And you can see that he says we are not the leader. This is what I was talking about, the control loop iteration. Let's go to the leader. So we'll find the leader. Don't worry about it. And you can see what the leader actually does. So this is the leader's probably going to be the second one, I bet. I just have a good feeling. No, that one's 100 seconds. It's going to be one of these guys, I bet. Or maybe it's going to be a new one. Anyway, either this guy's going to be a leader or he's not going to be a leader. I think this guy's a leader. I think I picked right. Yep. Okay. He's the leader because he doesn't say I'm not the leader. There's actually a message up top that says I'm the leader. Here it is. I'm the leader with token. So I picked the right one. So this guy's the leader. And so you can see what it does through every iteration. It goes through and it says, what's my cluster state, right? And it says it's got C, B, E, C, C, A, and D. Then it goes through and it gets information from each one of those guys. That's what the next section is, the peer info. So this is that gRPC service. What it does is the controller will send a gRPC request over to the peer. Based upon the member list, it'll say, okay, for this member, call the local gRPC service to get the peer info. And the peer info comes back, gets stored in the state running on the etcd manager controller. And what you see in the log file is that state being printed out. So I wanted to show you guys, so let me see here. Yeah, so, and then you'll see what the peer info thinks, what this peer thinks the cluster state is. So an interesting thing is, and I have a bug report open with the COPS guys on this. Interesting thing is that the cluster state, it prints out, the peer info that comes back from the remote peer, the cluster state, which is from that state file that I showed, that gRPC, or the protocol buffers file that I showed you guys, that feeds what's in the get info response that comes back from the peer. And sometimes that gets out of sync. It does get out of sync with what's in the current cluster membership. So I have a bug report open with COPS on that, and I was actually thinking about a way to resolve it, and I think I came up with a way to do it. And I was actually coding on that for this morning for like an hour, trying to come up with a solution on that. Okay, let me show you what I'm talking about. Let me go back here. So you know that I added 2 new members to the cluster. I added CA and CB. But this guy C was already a member of the cluster, and you can see that when he goes through, he thinks his version of the cluster state that he's got locally is, let's see, etcd state here. So in this section, where this is start, this is what he thinks the cluster state, this section right here. You see that he thinks the cluster is made up of C, D, and let's see, we got C, we got D, and that's it. And then obviously that's not what the cluster state really is. And then down here, there's inconsistencies in what the remote peers think the cluster state is, but it's kind of like a benign issue because that stuff. It really, to me, I think it only gets used when etcd manager gets restarted. You know, it reads that state file. Just if that state file is there, it knows that it needs to join a cluster that's already there. And when it joins a cluster, it joins the cluster with a token, and then that token allows it access to the cluster. And then the cluster state is going to come from etcd itself. It's not going to come from etcd manager. So it gets out of sync with like what the membership really is in the cluster at the time. So wow, everyone's drinking from the fire hose today. So I just threw like a slew of information. I highly glossed over a lot of this stuff. But hopefully, like today, I kind of gave you guys took away some of the pull back some of the curtains behind Etcd Manager. It does a lot more than what I've highlighted you guys, but just know that it does backups. So it does backups for you. It does version changes, so I could go and I can change the version. It does cluster expansion and cluster shrinking, and it keeps state in the Etsy host file. So that's when you see things in the Etsy host file is actually a good indication that your cluster expansion or shrinkage has occurred because the updates will happen in the Etsy host file. That actually is tied to etcd membership directly. So like when things come and go inside the Etsy cluster, it gets reflected in the Etsy host file. So that's like a true indicator. And then there's this like other state, which is kept by etcd manager that sometimes gets out of sync, but I think it's like benign because the master of the state is coming from etcd itself. So it's like two paths of state. It's kind of like a split brain kind of thing. But anyway, hopefully I pulled back the curtains on what etcd manager is and what it allows you to do. Yeah, so for next happy hour, maybe I'll try to do one next Friday. Keep it going strong. 2 weeks in a row. Past couple of weeks, I've skipped a week. I've been very busy, and maybe next week I'll talk to you guys about what I'm working on that week. I welcome suggestions if you guys want to send me notes about anything you want to talk about, and if it's something that I've dabbled in or I'm interested in, I could talk about it. But shoot me a note if you have any questions about what we did today. And everyone have a great weekend. I'll talk to you later.